And John, do you see the shape where it says polygon?
Right.
Okay, I'm gonna go here. And so what we're doing, well, actually, John, if you want to tell us what we're doing here, or this is a one-page sheet that a lot of our parents would see. This is just a very typical example of introducing something. Using those engagement norms that we talked about a few minutes ago, how would you go about teaching this to a student? This is a piece of paper, and I'm right next to my kid. What do you do?
Okay, so I think there's a lot of big words in here. And let's just, I think I'm just going to chunk read it. Okay, look up here, Joel. A polygon is a closed two-dimensional figure. Your turn, read.
A polygon
is a closed two-dimensional figure. All right, let me read the next part and then you read after me. Formed by three or more straight lines. Your turn. Formed by three or more straight lines that connect at vertices.
That connect at vertices.
Okay, now my job as a teacher is to show you what this means. So what is a polygon? First of all, it says closed. Closed means the lines meet. Can you show me your fingers? Oh, lines are meeting. They're not like this, they're meeting. Okay. Two-dimensional means it's flat. Can you show me flat? Okay, lines that meet that are flat. Three dimensionals like a ball or a cube. Okay. Three or more straight lines. Let's count how many lines we have right here. Joel, can you count the very first figure with me? 1, 2, 3. Okay, now they connect at vertices. Can you say that big word with me?
Vertices.
Vertices. Vertices is where they meet. Can you show me the little dots on there that are vertices? Yeah, there they are. Very good. Okay, so parents, this is actually how you teach this. Joel, can you just circle a couple of words up there?
Yes.
Closed, or underline will work. Two-dimensional. And what do we got? Straight lines and connected vertices. So what I did was I just took those words. I said, look, closed, they meet. Two-dimensional, they're flat. Three or more sides, let's count them. They connect at the dots. They're called vertices. We're not calling them dots, so we're calling them the vertices.
Oh, John, you know what I would do? I would add some spice to this and use a gesture. Vertices is where three or more straight lines connect. My vertices is right here and connect.
Well, it's two lines, where two lines meet. Where two lines meet. You have to have three straight lines, but where they meet, where every two lines meet is a vertice.
Oh, yes.
Every dot
is
a vertice. Great.
Yeah, very good.
By the way, it's your job as a parent to give feedback on any misperceptions your students have and make sure they understand it correctly. Now, Joel, this is a brain research on concept development. We show those examples across the top. The ones on the bottom, students, if you're still not sure what it is, look at the bottom one. The first one says not closed. That's not a polygon because the lines did not meet. The second one is not a polygon because it's a three-dimensional object. And the last one, we have curved lines. That's not a polygon.
I have my checking for understanding question, but if it's only me and my kid, like, do I just straight out ask them? How do you do that with them?
Well, I would have your child read. We have a question over. Let's read together. Which figure is not a polygon? How do you know? Now, I want you just to point to it. If you're right there with your student, they could just point to your finger. And we've got figure. Now, figure is a little drawing. Figure A and figure B. You're going to say figure blank is not a polygon because. Okay, so Joel, I'm going to ask you to point with your mouse or whatever you got. But at home, the student could point with their finger. Okay, so Joel, can you give me your answer in a complete sentence? Figure B.
Oh, it's B.
No, not it's B. Figure B.
Figure B is not a polygon because the lines don't connect at the
vertices.
Vertices.
Yeah, they don't actually meet. Remember we said a closed figure has to be, all the lines have to touch and be like that. Okay, very good.
Very good. Now, John, I noticed that whatever I say, even though I might have been a little bit off, you gave me effective feedback. You told me how to pronounce it. You prompted me, so I don't just use a pronoun, right? It's B. Right. I have to make the sentence. And then the third thing is you grabbed my answer and you elevated it. You use the academic language. You said it out loud one more time, didn't you? Now it's time for the curveballs. Looking at this, I know for a fact there's a couple things that you've been doing already, like literally, let's read the instructions together and things like that. He's just like you. You turned open the book. He has our engagement norms, just like this is, and he's hitting the standard. He knows he has to use language. John, you have the floor. No pressure.
All right. This could be a quiz or a periodic review, but you have to have taught every single thing on this page. And let's just look at that. Number 1 is subtraction. 2 is multiplication, division. Now notice that number 1 is not regrouping. It's just 9 minus 8 is 1. Now, number 4, this is a conceptual problem written in words. Divide 20 into 5 equal groups. They didn't just say 20 divided by 5 like problem number 3 did. So students need to be able to read. And we have to taught conceptually. Division means separating into equal groups. Addition is adding equal groups. So we have to have used that vocabulary while we're teaching. And probably some of that might be in the standards. Okay, now number 5 is place value. Okay, now this seems to be multiple grades. Place value is, this is like 1st or 2nd grade. Perimeter is 3rd or 4th grade. All right, so number 7 is perimeter. Now, Joel, look at the words. Calculate the perimeter. Do you see that? So we have to work with these words in the lessons. Questions 1 and 2 have no words in them, but look at question 7 has words. In fact, 4, 5, we've lost number. 6 is off the page, and 7 have words in them, and we have to be able to read and understand those words. Okay, 8 is is a measurement standard, and a lot of times we spend a lot of time on 1 and 2. We do multiplication, division. We don't get to the other strands. Measurements, probability, and those. So part of your job as a parent is to make sure you get to the other standards. They're all going to be tested. Now, number 9, again, we have to know the academic word, how to read it, how to spell it. And on a cube like that, you have sides, edges, and vertices. So this would be a side. Now, if you were doing this as a worksheet, you would have to have rule of 2. You would need to work a problem first as the adult, as the parent, to remind their students what these mean and have the students do a similar one.
So, John, if they're stuck on, let's just say here, number 4, if they're stuck on divide 20 into 5 equal groups, you're telling us instead of helping them solve this one, we come up with our own problem, divide 15 into 5 equal groups, divide 10 into 5 equal groups on a separate sheet of paper is what I'm hearing from you. Before we tackle this one, because I have to do one, explain my reason so they can do this one, is what I'm hearing.
Right.
Okay.
So you could do one first. Now, this is the problem. If you're doing worksheets like this with multiple concepts on the page, every one of these is an entire lesson. Perimeter, the theory of multiplication, division, cubes. So we got to make sure all these lessons have been taught. You can't just do worksheets like this. This could be periodic review, but not, if we do this every day, we're not actually doing instruction. We're just, we're answering questions, but everything has to be taught.
Fantastic. John, is there a duck in your office?
Yeah, the duck is my phone. Somebody's phoning me.
Okay.
I put the duck because everybody's phone sounds the same and you never could tell.
Well, let's make sure we edit that out on the recording video. Okay. This is one of the more popular math programs in use, and a lot of our parents are using this. Here's a filled out example, but I kind of feel like there's a lot of stuff going on here. There's a lot of conceptual ideas, conceptual development ideas.
Okay, well, let me tell you, this is the beginning of when you're teaching multiplication at the conceptual level. So 1A, 3 groups of 5 equals 15. That's what multiplication means. 3 times 5 is 3 groups of 5 added together. And then the very last one, 3 times 5, is what we need to memorize. The first one is what the concept of multiplication is, and the kids need to know the concepts. And then the last one is what we memorize. Just chant and remember that. Joel, I want you to look at the words in the question. Fill in the blanks to make true statements. Do you see the word statements?
Yeah.
So we need to make sure we're using the word statement someplace in our lesson, someplace the kids can read it and they know what that word means.
All right. So if I have my kiddo in front of me and we're going to do number 1, right? And
well, you might do number 1 as the parent.
Okay.
And then ask the students to do number 2 or number 3.
Okay. So I go
A, B, C.
Okay. So I go over here. Let's say I did number 1 and I go over here, number 2. And I'm going to have them do it. How do I get them to respond? Because I just feel like they're just going to write 15. what am I supposed to prompt them to give me an answer? How does that, what do they say?
Well, they should actually read the answer. 3 plus 3 plus 3 plus 3 plus 3 equals blank. And then when you do the second one, I want you to read your whole answer. You wrote 15, you read it. 5 groups of 3 equals 15. Other students read the whole thing. If they just say 15, at this point, I think we need to read the whole thing to practice the language. And reading math is a problem for students. Sometimes they can't read the math, especially you get older students, greater than or less than, they can't read the symbols.
How do I tie in the definition though? It says fill in the blanks to make true statements. How do I have them rehearse true statements? Because that seems important. Besides me saying, all right, Gina, look at me. Right now, track with me, follow along as I read. Fill in the blanks to make true statements. Read it with me, fill in the blanks to make
true statements. So a statement is like a phrase or a word or something you say. In this case, it's something we're writing down. So you're going to write a number in that makes it true. So 3 groups of 5 equals, you can't put 1 down there because 3 groups of 5 does not equal 1. That's not a true statement. So you have to give the correct answer to the statement. I'm just saying, Joel, you need to use this. And by middle school, when you start doing algebra, makes the equation true is one of the big phrases the students need to say. The value x equals 10 makes the equation true. And that's the way the students are going to have to be able to talk and be able to read and answer the questions. I want to go one more thing in my order of operations lesson.
Yes, of course.